Hi, I'm Dr. Colin Campbell. I'm a senior research scientist here at Meter Group, as well as adjunct faculty up at Washington State University, and I teach a class in environmental biophysics. And today, we're going to be talking about relative humidity. Have you ever looked at a weather report and wondered, what do they mean by relative? Why aren't we talking about absolute things? And so today, I'm going to talk about what is relative humidity. Well, relative humidity we're going to define here as just H sub r. And H sub r is equal to the partial pressure of water in air, water vapor in air, divided by the saturation vapor pressure, or the maximum possible partial pressure of water in air as a function of temperature. And so why this is relative is anytime we have a partial pressure of water vapor, we're always dividing it by the maximum possible water vapor that could be in the air at any point. So why would relative humidity be such a challenge for us as scientists to use in comparing different sites? I wanted to talk about that so we can focus in here on this saturation vapor pressure. Over here we have Tieten's equation. This says that the saturation vapor pressure, which is a function of air temperature, is equal to 0.611 kilopascals times the exponential of a constant b times the air temperature divided by another constant c plus the air temperature. So at any point, depending on the air temperature, we can calculate the saturation vapor pressure. And then we can put it back in this equation and get our relative humidity. There are two situations we might think about for calculating our saturation vapor pressure. The most typical is this one, where that constant B is 17.502 and the constant C is 240.97, and the units on this are degrees C, so these will cancel. If we're over ice, those constants would be different. B would be 21.87, and C would be 265.5, again, degrees C. So as I mentioned, relative humidity is a challenging variable to use in research because while vapor pressure, this EA, the vapor pressure of the air, is somewhat conservative across a day, the saturation vapor pressure with respect to air temperature, this changes solely with temperature across the day. So if we graphed temperature on one axis and the relative humidity on the other axis, we might, during a typical day, have a temperature range that looked somewhat like this. And because even if the vapor pressure, the actual vapor pressure EA wasn't changing, we'd see a relative humidity trend that looked like this, only changing because of air temperature. And because of that, if we wanted things like, well, how do I compare the water in the air at one research site, for example, with the water in the air at another research site, we might be inclined to average them. But because of this trend, the average of the relative humidity at any site tends to be around 0.6 to 0.65, and therefore it would be totally irrelevant in the literature. So we need to speak in absolutes. And in another lecture, I'm going to just go into what we can do to calculate that absolute relative humidity. If you want to know more about making measurements in the atmosphere, go to www.metergroup.com. Look at our atmospheric instrumentation, and you can learn more from there.